Hello, hello. How's everyone doing today? Hi, Webb. Hi, Lynn.
Hi, how's it going?
Oh, I am hearing an echo here, folks. Give me 1 second. All right, I think we should be good now. All right, so welcome everyone to another episode of Containers from the Couch. I am excited to have Webb and Lynn on today. Webb, of course, the CEO and co-founder of Stackwatch, the creators of Kubecost, and Lynn, solutions architect at Kubecost and ex-AWS. Let me pass it on to you guys. I'd love to get an intro.
Thank you so much, Sai. It is a real pleasure to be here. Pumped to talk about this new collaboration, between Kubecost and AWS to bring, great cost monitoring to EKS users. So, like Sai mentioned, my name is Webb. I am one of the co-creators of, Kubecost and OpenCost, and I'm joined by the amazing Linh Lam, who is a solutions architect on the Kubecost team, and is going to be doing a lot of the demos, the fun stuff today.
Hi everyone, I am Linh Lam, solution architect for Kubecost, and I am also the ex-Amazonian as well. Nice to meet everyone.
Awesome, and welcome to the show, folks. This is an exciting one. So, as you mentioned, there's a new integration, a new collaboration between Kubecost and EKS here. So, folks have been able to use Kubecost with EKS, but we're bringing out something new here today, and I'm excited because Lynn's got a full demo for us. And Webb, I want to pass it to you to kick it off a little bit about what exactly is Kubecost, why is this important for customers and users, and a little bit about what you folks have created over at Stackwatch.
Yeah, absolutely. So like I mentioned, general plan today is to give just a really quick overview, some background context, and then spend the bulk of our time really diving into a demo and showing you a solution that you can go and use today, install in minutes, if not shorter, and get valuable insights in EKS environment. Lynn's going to talk in detail about kind of how we've done that integration and how Kubecost is being optimized for EKS users, as well as the support from Amazon. So more to come there. I want to start with just a little bit of background context around the challenges that we're helping solve here. So first, at this point, it's no surprise that we're seeing just mass adoption of Kubernetes, in many different scenarios. I've heard of Kubernetes going to space, going in cars. It is amazing to see just the broad, adoption. But based on a CNCF study from last year, the majority of teams don't have accurate cost monitoring, right? So that study showed that only around a third of teams actually have accurate cost visibility. And what we've seen is that it is really challenging for teams to go all in at scale on a solution when they have limited visibility into where their spend is. So users have really stated that they want a number of things out of the great cost monitoring solution. They talked about how they want to be able to really track Kubernetes resources at different levels that are relevant to them. That could be by cluster, by microservice, by namespace, by label, annotation. There's many different ways that teams architect or organize their applications or services. They've also talked about how they really wanted fine-grained visibility. So the ability to drill into individual pods, jobs, containers even allows teams to take action on that information. And lastly, they want to be able to break down all of their EKS charges and distribute them across teams, even doing accurate chargeback where organizations or departments are actually billed for their spend and kind of accountable for it, if you will. And lastly, again, they wanted to be able to go and act on all of this information. So from an optimization perspective, finding that right balance between cost and performance or cost and reliability. So this collaboration is really aimed at tackling that and providing a free and open solution that can be installed again in minutes, if not seconds.
That's pretty cool. And I'm honestly not surprised by those survey results that so many don't have accurate spending tracking in place, because at the end of the day, with Kubernetes, with containers being ephemeral, and we're treating applications as cattle, not pets, right? And so there's all these types of different approaches to track how you're spending with Kubernetes. And I know we're going to get into this in a little bit here, but Kubecost gives these really interesting ways of tracking it. I know you have things like cost efficiency scores and that kind of thing, and health scores as well, which I was just talking to Lynn about this earlier, which is such an interesting way of making this tracking of the data and almost gamifying it. But again, maybe getting a little ahead of myself. But I'll let you kind of go back here with the slides here. What?
No, I think that's an excellent rundown of kind of the practical or even the technical challenges, which is like Kubernetes environments tend to be so dynamic. Things tend to be co-located or multi-tenant, sharing a lot of resources. So going in there and untangling that and doing this accurately is a complex problem, and one we've been working on for given our experience at Google before starting Kubecost, we like to say better part of a decade, but on Kubecost for more than 3 years now. So related to that, like the Kubecost open source project was created to really help teams understand and then optimize their Kubernetes spend, again keeping in mind their balance and goals around performance and cost. So the open source project was launched in April 2019. The bulk of that open source, the original open source, and then a lot more code that's been contributed since then, is now the OpenCost project. It is a new CNCF project. There's two parts to OpenCost that are really interesting. It is like the implementation of which all of Kubecost products are built on top of. That's like an internal cost engine that powers all of our kind of accurate visibility. And then there's also this like spec that we built with a number of like great ecosystem, like partners, and including AWS and others, to actually lay out the definition of how you do this accurately, right? So thinking about not only usage, for allocating costs, but also things like Kubernetes requests, that sort of stuff.
Webb, I love the fact that this is backed by that open source project. But very quickly for our viewers, Kubecost itself, especially the integration we're going to be talking about today with EKS, is available for free, right? And so when we talk about OpenCost, what components of Kubecost are in OpenCost? And for our viewers out there, when would it maybe make sense to start with OpenCost rather than Kubecost proper?
Yeah, great question. So the way you can think about the relationship between OpenCost and Kubecost is that OpenCost itself is like the core allocation engine that all of the calculations and visibility of Kubecost is built on top of. So OpenCost is able to tell you, the cost of a container or pod, namespace, et cetera. It is tight, has a pretty tight relationship with Prometheus, open source, time series database, so that you can say write metrics to Prometheus. You can then, query that. You can, put alerts on top of that. You can do a lot of custom things on your own. Kubecost takes that library and has a more kind of, a broader set of UI built on top of it, more robust insights built on top of it. So it really extends that project in many ways. Both are free and available. Kubecost itself is actually built on multiple open source projects. So I think it depends on the use case, but we are seeing more and more teams, take OpenCost and integrate with OpenCost. So it's a brand new project, exciting to see where that evolved. But at the end of the day, we think of kind of like Kubecost as OpenCost plus, if you will. We're taking that open source library and adding other enterprise functionality, other functionality on top of it.
That makes sense.
Cool. So just a little bit more here, and then I can hand it over. Just for context, we've got more than 5,000 teams running Kubecost across all environments. Really interesting. Most teams aren't familiar with this. Kubecost itself can actually be run on-prem or even air-gapped environment, right? So like it doesn't egress any data. It doesn't need to like, send any data to like Kubecost servers. It is like, all run, locally. And our kind of, business model, if you will, is, we sell enterprise, solutions, via an open core model on top of, free Kubecost. And that includes like, training and services. And yeah, we've got a team of, 55 today and are growing kind of on all fronts across, engineering, support, and much more. So with that, I'll turn it over to Lynn to talk a little bit more, and then really dive into a demo.
Yeah, thank you, Webb and Sai. And I'm really excited to show you the Amazon EKS Cost Monitoring solution using Kubecost. So this is the collaboration between AWS and Kubecost to deliver a cost monitoring solution for Amazon EKS cluster to solve the challenges that Webb described earlier in the first couple of slides. So for the demo, I will jump back and forth between the slides and my console. So please bear with me here. So first, let's get into the pre-setup environment. This is the demo environment that I set up a couple days before on an Amazon EKS cluster. So first, when you install Kubecost on Amazon EKS cluster and expose this, the first view that you see is the overview page that gives you the overview picture of the cost of your EKS cluster. And from here, you can deep dive into the details of the cost generating by the computer application running on your EKS cluster. So first, let's get into the cost allocation view. So this is the main name of the game here. This gives you the visibility into the cost of your community application aggregated by all of the community's native concept. So the default view that you are seeing here is breaking down by or aggregated by the namespace, but you can also modify this view to for your purpose as well. You can aggregate it by different Kubernetes concept, for example, by the deployment of the Kubernetes application.
So Lynn, I have a quick question here, and I hate to interrupt your flow here, but I've got to ask. So this is a Kubecost environment that you've already deployed into an existing cluster a few days ago. Now I have experience with things like Grafana, and I'm told I can use Grafana to make really cool dashboards that look like this. Just to level set here, how much manual work did you have to do to get this dashboard up and running?
Well, I would say it just takes me like one installation command to get it up and running, because all of this dashboard has been rebuilt into the Kubecost. So technically, you don't really need to do much or do anything. So you just need to install the Kubecost on Amazon EKS cluster, and all of the view or dashboard will be rebuilt for you to customize as well. As I'm going to walk you through in next couple of steps as well. And I will also show you how it can be done in the installation demo later in this session.
So these are all kind of reasonable defaults and automatically created dashboards.
Correct.
That's pulling. That's pretty cool.
Yeah. Great question, Sai. And one thing also is because we write all of our metrics, Kubecost writes all of its metrics to Prometheus. We actually have kind of optional some default Grafana dashboards, or teams build their own Grafana dashboards as well. So there is that ability to build totally custom, or even like integrate cost metrics into your existing dashboards.
Yep, there's a lot of flexibility here. And with our default dashboard, you can do a ton of customization as well. So like I mentioned, you can aggregate the cost of your cluster, the allocation cost of your cluster by different Kubernetes contexts like deployment, or you can select multiple aggregation as well. Let's say you would like to break down your cost by the deployment of every namespace. You can select multiple aggregation here, and the dashboard will change immediately for you, so give you the best visibility for your need. And you can also, the other cool thing is that you can also change the further setting on how the dashboard display for you as well for your purpose. Like you can basically just show cost breakdown by different context here, or like just get back to the cost over time, which our customer love the most. And when you satisfy with the view here and it's meet your requirements, you can also save the report here for later use or share with the other team to for the maybe a show back or track back purpose as well, right? And like for the developer team or financial team, you can share the dashboard to them, or if you would like to share the data, the cost data to your executive team, you can also download it as a CSV file, like just one click like this, and send it over to your executive team real quick.
So what I can see here is that in multi-tenant environments, say you have multiple teams using the same cluster, maybe separated by namespaces, this will actually help you break down what each team is spending on a single cluster, right? I think this is probably a pretty common request.
Yeah, it is correct. And when looking into the cost from Kubecost, we will recommend you to look into 3 different categories here. The first one is the in-cluster cost, which is the CPU, GPU, RAM, persistent volume, network, and load balancer. This is the in-cluster cost generated by the Kubernetes application running inside your Kubernetes cluster. And the second category here is the shared cost. It is the cost of the resource that using by multiple team or multiple namespace. For example, like the monitoring application like Prometheus or some logs application, or even the if you use the Amazon EKS, you can also uh, include the Amazon EKS management fee into the checkout and distribute it proportionally or evenly among the team inside your EKS cluster as well. So it's really cool. And the third one is the efficiency of your allocation cost. So the efficiency here, you can look at it like a utilization of the requested resource. You can see how efficiency is for different team when they use the utilize the requested resource that assigned to their specific namespace or the specific team here. So using this number, you can identify like the waste of your Kubernetes cluster and look into how to reduce the waste. So let's do an example here. So I see the Mimir test namespace here has pretty low efficiencies around like 14 or 15% only. And I would like to drill down into what component that I would like to have like a better picture of what uh, how the other component is utilize the resource assigned to this namespace. You can just click on this and it will drill down into different component of the namespace up to the container level of the application. So next, I will just maybe click on the Mimi Store Gateway here. This could take me to the pod level, and I see one pod Mimi Store Gateway running here with the efficiency of 5% only. And I can click on it, and it will take me to give me the information of how the pod running, how the container inside this pod is running, and consuming the resource, and how much cost it is for this specific container.
So Lynn, it might be helpful to very quickly, what was that tooltip when you hovered over efficiency? So how is that percent actually being calculated?
So the percentage of the efficiency is calculated by the usage over the request resources. So let's say you request for 5 gigabyte of RAM, but your actual usage is only 1 gigabyte of RAM. So the efficiency here is only around like 25%, right? So there's a use case that your request, you under provision your community application. Like your application requests 2 GB of RAM, but the actual usage is like 5 GB of RAM. So the efficiency score would be over 100%. So let's get back to the cost allocation default view, and I have an example for you. So you can see the efficiency here for the under provision resource is like over 100%.
Yeah, I think the one interesting like nuance to add to that is this is a cost weighted measurement of efficiency, right? So let's just say you're using a handful of spot CPUs versus a handful of on-demand CPUs. Given that on-demand CPUs are more expensive, it's going to be more likely that those CPUs would be driving the like utilization figures. So I think it's really interesting, like place to point to think about just if my goal is to like manage cost, this is going to give you the like directional accuracy of where you should be investing time. And then second part is this is all based on the OpenCost spec. So you can go see the like pretty detailed. I think the spec is probably 10 or 12 pages now approximately, and so you can go see the kind of nuances if you're interested there, and open to community feedback and contributions as well.
Awesome. And so, Lynn, with these different efficiency figures you're showing, does this basically mean we need to optimize the CPU and memory requests of these actual workloads to be closer to what they're using? Is that a reasonable takeaway from that data?
Yeah, that's correct. And Kubecost can also give you that kind of recommendation as well. So on the same view, let's say click on the application that I show is under provisioning. So when you click on it, it will take you to a detail base where you can have a better picture of the resource running inside this specific namespace, right? And when you're going down, I can see that one of my test application here, which is the PHP web application, is being under provision. So I will click on it. So when I click on it, it will take me to the request sizing recommendation, where it's give me more details about how the how utilization it is for this specific deployment. And Kubecost also gives you the recommendation based on the actual usage of the CPU over a couple of days. They give you the CPU recommendation that can help to stabilize the application and reduce the risk of the application being terminate by Kubernetes when the node is ran out of the resources. So you can see the CPU recommendation here based on the actual usage is around 459 millis CPU, and the RAM recommendation is around 25 megabyte.
Okay, awesome. What does that big blue button do? The automatically implement?
Oh, that's one. So this is one of the cool feature that I really love about Kubecost. Is if it is optionally you can enable this feature that's called automatically implement recommendation. When you enable it for your Kubecost setup, when you click this button with like just one or two click, this can automatically apply the recommendation from Kubecost to the resource and modify the resource for you automatically. So you don't have to manually go to your Kubernetes cluster and change the configuration. So it's really cool feature.
Part of me gets really excited to see that button, and it's like, oh wow, this is like an easy button. But then the other part of me is like, this is going to cause some major configuration drift if I don't have like the right GitOps based approach for my deployment, right? Because I'm changing something in maybe staging or prod or wherever this cluster is, but that might not get reflected down in my actual GitHub repo where I have the configuration itself. Is that something that Kubecost has thought about, and you folks have thought about maybe integrating with the actual config repository itself to automatically check in updates like this?
Yeah, absolutely. It's something we've talked about a good bit, and we currently provide a couple of different paths, and I think like Kubernetes, we tend to take that same approach of we want to try to give like a range of flexible tooling and let teams like integrate it in different ways. But we have integrations with things like Spinnaker where you can actually apply these as part of your like deployment pipeline, so that every time you go through a deployment with an application, it picks up the same recommendation. We think about this as being similar to when it's not in a deployment pipeline, being similar to like an auto scaling rule where like teams can recurringly apply these. And you're right that there may be drift, but as long as you have the like data and the like frameworks and the automation to get back to where you were, should like a service go down or a cluster go down, even that's really valuable. So I think it's something. So I had something interesting, and I don't know if you've had the discussion recently on the podcast, but really interesting to think about, because auto scaling configurations, like by definition, create drift, right? But you still have the rules and the like frameworks to get back to that point. Should you like have a cluster, namespace, et cetera, go down.
Right. No, that makes sense. In a sense, you could have the rules themselves hard coded and then use this as a kind of live recalculating way of setting the limits. Now, we've had a couple of questions come in related to Spot. So I want to take a quick break here, Lynn, and I want to raise a couple of these. So one of the questions from Tinashe Chipomo, he's interested to know if Kubecost can show costs per instances launched. So not exactly the workloads, but the instances themselves. And then, as an example, for Spot instances that could have ran for a few seconds.
Yeah, and Lynn, you want to take this? I also see that someone in the chat has also provided a helpful answer there as well.
It is possible for your question. That is a great question. Yeah, for your question, it is possible to do it with the cloud integration, with AWS cloud integration. Basically, you give Kubecost permission to read AWS cost and usage report, and we can, based on that cost data provided by AWS, and reconcile with the cost allocation data and show you the cost of the EC2 instance or Spot instance. You can also integrate with the Spot instant data provided by AWS as well. So on this view, this is where Kubecost show the cost related to the underlying infrastructure of your Amazon EKS cluster. And optionally, if you have integration with the AWS cost and report data, it can also show the cloud spend of your AWS account specifically as well. So let's change the view to the cluster, so we can see the specific cost to the cluster. So if your EKS cluster running on the Spot instance, you can click on drill down into the specific EKS cluster here, as will give you the visibility of the cost of your workload as well. So similarly to the cost allocation.
And so, Lynn, this will also address nodes that come up ephemerally. So, for example, I see a couple of questions in the chat. So if you're using something like Cluster Autoscaler or Carpenter, and those are, Carpenter enables you to spin up Spot instances in response to increased load, right? So in those cases, when these nodes are coming up for a short amount of time to run some workloads and then they go away, is Kubecost able to track those nodes even when they're ephemeral?
Yeah, it should be able to. Webb, you can keep me honest here, but when it's come up into the and reported by the AWS cost and usage data, Kubecost can pick up that information and show it in this view here, and you can click on each specific instance to see the cost associated with it for the specific data has been up and incurred cost.
Yeah, that's exactly right. And I see Jonathan Phillips in the chat shared that as well, which is because Kubecost is tightly built with alongside Prometheus. You can think about it as if you're familiar with Prometheus, you can configure this scrape interval, and you've got a lot of flexibility. You can scrape every second, you can scrape every 10 seconds, you can scrape every minute. You have a lot of configuration options available there. And then second, like Lynn mentioned, is by doing the optional integration with your AWS account, you would then get not only accurate pricing for spot instances. You'd also get accurate pricing for like EDP programs and, savings plans and like, reserved instances, et cetera, et cetera.
Yeah, I think it was on a previous slide or a page that you were showing here, Lynn. I saw a column for credits and I was like, how could that be? How could you show the credits? How do you even know this? Because I'm assuming you're pulling the cost information from, the AWS public pricing API. So I think it's interesting that you can make that integration with our cost and usage reports, right? I mean, is that, can you talk a little bit about that integration, Lynn?
Yeah, Webb, would you like to take it?
Yeah, happy to take a first shot, but please feel free to add more, Lynn. So yeah, it's a totally optional integration, right? You can Helm install this, like product without doing that. And just like you said, Sai, it would by default be using like public, AWS, like rates. Once you do that integration, we would do two things. We would start like inferring and learning based on like historical data, right? So like we would see that this, like node class has been, discounted historically because of an EDP program. But we would give you those like estimates in real time, right? So you can like make decisions. Typically they're like, 95+% accurate. But then once that bill is available, it would go to like, 100% accuracy. So that's like super, super important here to like let teams, make decisions and rely on these figures, that like level of accuracy, right? So like we definitely recommend teams that are going to be moving this data or using this data in production to like do that integration if they're able to.
Awesome. That's very cool. Some more questions. This is awesome. I'm seeing a lot of really good questions here. Can Kubecost capture underlying EBS costs, including snapshots? So I think broadly, I guess another way to ask this would be, is Kubecost able to manage expenses outside of Kubernetes itself, right? So unallocated things. So RDS instances, S3 instances, S3 buckets, underlying EBS. How can we, can we track this with Kubecost?
Yeah, we can do it under the access view, like I mentioned, with the optional cloud integration with the AWS cost and usage report data. You can also see your cloud spend for different AWS services that show up here. So for the EPS, I think is also showing here. Or I can just pick one of the specific AWS services, for example, like Amazon S3. It can show you the information of the S3 cost of your specific AWS account as well. So one of the things you can see here, if you aggregate cost by the cluster, you can see what cost is associated with your specific Kubernetes cluster and the cost of your AWS cloud that not tied to the Kubernetes cluster. So you can see the difference here from one of my test AWS account.
And I'm seeing tags there. Is that how it works? How is it able to know this data? So you mentioned it's integrated with cost in usage reports, which is kind of the built-in billing dashboard in AWS. So obviously anyone could use that today to get the data, but to pull it into this dashboard it's pretty valuable. How is it doing that?
Yeah, so for the Kubernetes application, let's say your Kubernetes application connect with a specific AWS services, for example, like S3 or IDS, and you would like to tie the cost of that AWS service back to the Amazon EKS, to the Kubernetes cost. You can just enable a tag on AWS and tag it appropriate, tag the AWS service appropriately, and Kubecost will pick it up when reconcile the cost data from Amazon cost and usage and show it here in the dashboard for you.
Very cool. Okay, so I do want to let you continue your demo here, Lynn, but I have one last question. I brought this up earlier. It's almost like you guys have gamified some aspects here. So in the main view, there was that cost efficiency percent. And I know that if I was an ops engineer, I might obsess over getting that to as close to 100% as I could. I know you also have a health score. So you have these kind of grading mechanisms of how the cluster is performing and how efficient it is. But okay, once I have that, what's my next step? How do I start fixing some of these things? And you showed the one thing with the resource size limits and automatically setting those. That's pretty cool. What else can we do? What else can we see in this dashboard?
Yeah, we give a different saving recommendation for different thing as well for your Kubernetes clusters. So you can on the Kubecost UI, you can discover a view here, and it's give you the total cost of how much money that that estimate cost that you can save by apply the recommendation. So one of the things that I just showed you earlier is the right size your container request, and Qcost also give you a different insight or recommendation into different thing to save the cost for you as well, like the abundant workloads. Let's say that I test some application I started and I forget about it and leave it run over the weekend without using it, so it just generates some waste here. And Qcost can base on the network traffic of that going in on and going out of that application, and give you the suggestion of which application that you should look at and consider to maybe terminate it to save the cost. You can set the threshold here for the network traffic, like if it's less than 500 bytes per second within 2 days, you should consider to stop that application or terminate that application. Another cluster saving recommendation that you can look at is right side your cluster node as well. So when you click it here, it will, based on your actual usage, it will give you the recommendation of what instance type that you should use and how much cost that you can save per month, for example. And yeah, there's a ton of things that you can look at here in under the saving recommendation. So Webb, do you have anything that you would like to add here?
I would just say maybe one of the questions that was mentioned earlier, we do have some insights that would kind of be outside of the cluster, right? So like unclaimed, like external IP addresses, that aren't being used, that sort of thing. So if you do have like other, insights you'd want to see, like let us know. And then, yeah, I think, one thing you've seen in a couple of these recommendations and side to your question earlier is that like, when you're, say, right-sizing a request or an application, you really want to be thinking about the like context / like, SLAs or requirements of that application. And, one example would be if it's a dev workload that, yeah, it's okay if it gets CPU throttled, here and there, and that's okay, versus it's an HA application or an HA service that like absolutely, need to be performing at, say, 5 nines of uptime. You're going to like treat those, very differently, right? In terms of how you think about setting requests, limits, and just like overall capacity, as well as like, noisy neighbor concerns, that sort of stuff.
Definitely. And as I'm going through this, I've got to say this. So a lot of these kind of recommendations, it's reminiscent of what cluster autoscalers do. And one that is on top of mind because they just recently announced this feature. It's Carpenter. They recently announced this feature called workload consolidation. So Carpenter is an open source cluster autoscaler, and I'm looking at right size your cluster nodes and right size your container requests, and a lot of this stuff is what Carpenter does today. And even in the chat today, we've had a few questions come up about Carpenter. Have you guys considered potentially integrating or being able to pull data from Carpenter? Is this something that's on your radar for integrating with cluster autoscalers?
Yeah, we think it's really interesting and are like, open and interested to like exploring more there. What we view is we're bringing this like very cost aware, set of metrics or language to where you can now make these really accurate and precise trade-offs, right? To say, for an organization, for example, like, what it would cost to spin up an M5, X large in this particular region is going to be different for every company. Again, given EDP discounts, given that they may be in one region versus the other, that sort of stuff. So being able to like answer that in real time, we view as like an incredibly valuable input to a lot of these, decisions being made, like autoscaling.
Yeah, definitely. I do kind of see them on two separate kind of scopes, right? Because with Kubecost, I definitely see it more as like an observability, visibility tool to give you the ability to even understand what's going on in your cluster. Whereas Carpenter on the other side and these cluster autoscalers are implementing certain very specific cost optimization techniques. So definitely two different sides of the puzzle here. But maybe I should back up here. Would you agree with me that Kubecost can kind of be seen as an observability, monitoring, visibility type tool, or are you breaking into kind of more than just that?
Yeah, so we kind of talk about some of the pain points that a lot of users have been talking about, and that is definitely, the primary one we're focused on, right? Which is most teams don't have great visibility, and therefore, having a culture of awareness and transparency is like really hard, if not impossible, without that. So that's like our primary focus. But we do want to give tools either the like integration or like direct support for things that will help them again find this right balance between performance and reliability as well as cost. So we are very open and excited to if that's to integrate with other open source tools. Like we have some visibility into the open source cluster autoscaler already, and think there's a really cool opportunity to do something like that with Carpenter and other solutions.
Very cool. All right, Lynn, I feel like we've interrupted your demo enough times now. I am very curious. I know you had mentioned you wanted to show how you install this as well. I think folks would be very interested to see that.
Yeah, thank you, Sai. Those are all great questions. It's give me the opportunity to show you more about how Kubecost solve the customer challenges as well. So before jumping in the installation demo, I just would like to summarize a little bit about the benefit of this collaboration that we and Kubecost and AWS have to deliver to the customer. So with this collaboration, we deliver an optimized bundle that built specifically for Amazon EKS cluster. It has been tested and verified by both Kubecost and Amazon EKS team. And we provide this optimized bundle for free to the customer to install on their EKS cluster. And by using this optimized bundle, you will receive the best-in-class customer service from both AWS support team and Kubecost support team. And all of the container images and the ham drag of this optimized bundle is hosted by Amazon ECR Public Gallery. So it's on its way publicly available and highly available for you to consume. And next, it is really easy to install with a single ham install command that I'm going to show you in the demo. So let's switch to the demo and see how easy it is to install Kubecost in just like a few minutes. So this is my Kubernetes IDE, and I will use this to install Kubecost on the existing EKS cluster that I have. So to install the Amazon EKS Cost Monitoring with Kubecost, you can just copy and paste this ham install command that going to boot the container image and ham drag from the ECR public gallery using the optimized configuration provided by Kubecost and AWS here. So just hit enter. And waiting for a few minutes, Kubecost will be up and running real quick. So you see it starts installing Kubecost on the EKS cluster right here. So typically it would take around like a couple of minutes for it to be fully available. So I will take that opportunity to share with you more about the architecture of this integration. So technically, when Kubecost being installed on the Amazon EKS cluster, it is installed with three core components, which is front end, cost model, and Prometheus. So front end is based on Nginx. The front end will be responsible for handle the handle the request and routing the request to the backend, which is the cost model and Prometheus, and show the cost allocation data back to the Kubecost dashboard for the customer to consume. And cost model here is acting as a backend for the API calls from the front end or from the customer environment. It's also ingest the metric from the AWS public pricing data when it starts to perform the cost allocation um, calculation, then expose it to a matrix endpoint where Prometheus can scrap to get that data and store it inside the Prometheus. And the Prometheus here has two key functions. One is it's going to scrap the matrix from your EKS cluster and from different component of your EKS cluster as well, like CAdvisor, node exporter, and the Kubecost itself. Store all of that matrix inside Prometheus for Kubecost to consume later on. And optionally, like we mentioned before, you can also integrate Kubecost with the AWS cost and usage report data, so Kubecost can provide more accurate pricing information, and it can reflect the specific pricing for your AWS account as well. Like if you have enterprise discount program EDP or savings plan, or you just purchase reserve instant or spot instant.
So, quick question here, Lynn. So, when you're working with this EKS optimized bundle of Kubecost, is it just as easy to get started as if you were working with open source Kubecost? Is it easier? And I guess one specific question is, for things like Prometheus, are you responsible for deploying and managing that yourself, or does that kind of come as part of this bundle?
So, compared to the OpenCost, this one would give the customer more seamless experience. So you don't have to tie all of the component by yourself, but you just need, like I demo, just install with a single command and everything is set up for you. And the configuration here is already reviewed and tested by both AWS and Kubecost to optimize for the Amazon EKS cluster. And we also continuously working on it to improve and deliver more values to the customer as well.
Got it. And it seems like Prometheus is such a critical part of this. So here we can see it's scraping Kubernetes for kube data, of course. It's being queried so that Kubecost has the information that it needs. And then lastly, I think this is the critical thing. In the beginning, I was wondering, where's Kubecost storing this? Is it ephemeral? Is it in cache? It's writing that data back into the Prometheus, right? So it's that data is being stored there. So Prometheus is kind of this really critical part of this architecture.
Yeah, it is correct. Prometheus acting as a critical part of this architecture, and we also hear from many customers that they also want to abstract away that maintenance and scaling Prometheus tasks away from their team as well, which I will show you in the next demo installation for the new integration that we just launched with the Amazon Managed for Prometheus team last week as well. So stay tuned for that in the next installation.
And just to really quickly add to that, Ty, like we touched on it briefly earlier, but the core reason for why we did that is we saw so many teams running Prometheus and and or hotel collectors, and we're like big believers in just open interfaces and open standards. We saw this as really valuable because again, teams oftentimes already were comfortable or familiar running Prometheus, have a Prometheus deployed. So with that, again, you could take this data and take it to Grafana. You can, use Alert Manager on top of it. You can write, cost related or efficiency related queries directly. We are big believers in the power and flexibility of those open solutions to give teams just a whole range of ways to view and manage cost.
Yeah, so our installation should be ready by now. Before I get into it, do you have any question here or anything we can answer for you and the customer here?
I think we're good for now. If there's any relevant questions, I'll bring them up.
Yeah, sure. Going. Those are all great questions. Thank you, Sai. So you see that just 5 minutes or maybe less because we've been reviewing the architecture. All of the component of the Kubecost has been up and running. And next step is for the demo purpose, I will just expose it to my local machine here to access it. But you can expose it in different way. You can use your ingress. You can create an ingress to expose it, or different way based on your organization requirements. So get back to the browser here. I have it at localhost. So yeah, just refresh it, and you can see the initial data start flowing in, give you the visibility into the cost of your EKS cluster. So this data are going to be built continuously. So the best practice here is you will get better data after like a couple of days when the Kubecost has better operators would get more data around your Kubernetes application usage and give you a better visibility into the cost data here. So it's really quick to install and start using the Kubecost. And next, I will show you how to integrate this current setup with the Amazon Managed Prometheus. It is another easy process with just a couple of comments as well.
And good timing as well. We just got a question from Sam asking, is it possible to use a deployed Prometheus instead of one bundled with Kubecost?
Yes, it is. It's really easy. You can just need to tell Kubecost where your Prometheus is during the ham installation, and it can pick up from there and use your, I would call it your managed Prometheus, your own Prometheus instead of the bundle Prometheus come with Kubecost.
Let's see it.
Yeah, so that setup is kind of similar with Amazon Managed for Prometheus, but it's a remote Prometheus. So there's some more advanced thing for the customer experience. So let's dive into the installation process here. So get back to my IDE here. Let me stop forwarding the part here and then click for easier to follow. So we already have the Kubecost set up and running, and now we would like to use Amazon Managed Prometheus as Prometheus compatible start to start the Kubecost metric instead of using the bundle Prometheus. So to do it, you need to set up an Amazon Managed Prometheus instance. I installed it already. I have it provisioned already for the demo purpose, and you can see I'm going to use do it on my existing cluster here, which is Link EKS test in the US West 2 region, and this is the ID of my current Amazon Managed Prometheus workspace, and I define the remote write endpoint and the query endpoint here. Next, I'm going to set up the IAM role for service account. This is one of the things I love the most about this integration. It's help Kubecost to communicate with Amazon Managed Prometheus in the passwordless using the passwordless method. So with this, you don't need to worry about like expose your credentials, accidentally expose your credentials, and reduce the risk of the being attacked by the malicious user or people. It will take approximately like 1 or 2 minutes here to install.
Cool, Lynn. So while that's happening, maybe we can run down a few of these questions real quickly. Yeah. There's a question here: can we track down the cost per pod namespace? I'll take this one. Yes, Srinivas, you absolutely can. I think in the earlier part of the demo, we saw not only how to track down with pod namespaces, but through a whole different set of heuristics that can be customized. So yes, absolutely. We have another question from Khalil: can we use Kubecost with Datadog? And I just kind of want to understand what the angle here is. I'm going to assume the answer is yes, because we're writing to Prometheus all of the data at the end of the day. So if you wanted to use Datadog, you could feasibly just pull that data from Prometheus, right, guys?
Yeah, that's exactly right. We've got a bunch of teams doing that today. Absolutely.
Awesome. We've got another question from Anuj. Can you demonstrate how to import the CUR data cost and usage reports? Lynn, I'm not sure if you were planning to demo this, but this is one of those optional integrations to get that more accurate data, whether you have enterprise discount programs, reserved instances, spot, those kinds of things, right?
Yeah, so we have just a few minutes left here, so it could take more time. So I can share, if you contact us, I can share with you the documentation on how to do it. And it is just a kind of easy process to do. And we can
Awesome.
contact
And
our team, and our
Lynn,
team can help you with that as well.
yeah, and Lynn, just a heads up, if you want to run a little bit over, a few minutes over, fine with me. I do want to be respectful of your time as well, though. And folks, I just dropped a link in chat. If you wanted to contact the Kubecost team for more information or have any questions, you can definitely do that. Let's see. I think there was one more question here that I wanted to highlight. Is there a daily, weekly chart or heat map showing cluster utilization by the hour? And as a follow-up, it's so that they can identify if they should run empty clusters on nights and weekends, coming from clusters used for heavy data processing.
So I don't know exactly the use case, and please feel free to follow up with us. And Lynn, I don't know if you have that cluster open now, but there actually is, I think, what you're looking for, which is a view of cost allocation. And then if you, Lynn, go from instead like time series data, you should have a different view. So yeah, instead of cost over time, let's see if we can get your tree map. So that is, I don't know if we would call that a heat map, but I think that is directly, and so the size of each, like component would be a function of its cost. And then the color would be based on efficiency. So if you have feedback or feature requests here, please reach out. We'd love to hear.
Awesome.
Yeah.
Lynn, I think that's all the questions for now. I'm guessing that integration should be up by now.
Yeah, sorry. I think there's something wrong with my infrastructure right now, because it seems like
that's
it
funny.
gets,
We got a comment
yeah.
saying US West 2 might be having a bad day.
Oh, I see. That's
Possible.
why. I see.
The
That's
demo
why
got
my comment
found on
doesn't
you
go
today,
through.
Lynn. I'm sorry.
Yeah, no
But
worry about that. But the nice thing is that the environment that I just used to show you, to demo you, is actually integrated with the Amazon Managed from Prometheus. So this is actually already connect and using Amazon Managed from Prometheus already. So I can show you real quick after you install it. So let's get back to my IDE here. I have it set up in a different namespace. So after you fully integrated with the, I would call it AM right now. With AM, it will look like this. And the what change is that it's going to add the new container as a sidecar here, acting as a proxy to allow Kubecost does the query to AM without using a static password. And get back to the architecture here, I can show you how it's actually work. So similarly to the standard Amazon EKS Cost Monitoring, when you integrate with an AM workspace, it's going to add the new proxies here. This proxy will handle the query from Kubecost and redirect it into the AM using the SIG-V for authentication protocol to reduce the security risk of exposing your credential while does the query. And how it's work is Kubecost query the data directly to the proxy, and the proxy forward that query to the AMP and return the data back to the Kubecost. In the meantime, Prometheus will continue to scrap the data, but now Kubecost doesn't query the data directly from the Prometheus anymore. The Prometheus only rewrite the metric that is scrapped to the AMP space and store it inside the AMP space here. This is how the integration work with the AMP work. Yep. Please go ahead.
So Lynn, I just wanted to ask, so the benefit of this is that, say you're running Kubecost in multiple clusters, multiple environments, and you want to stream all the data to a single place, and also kind of just for scalability concerns, I would imagine using this as a benefit. But I guess one more, so that Prometheus pod, that's being used as just the collector. So I'm guessing you don't have to run as much Kubecost backend on the cluster itself when you're following this architecture, right? So you can kind of save some cluster space by using this managed Prometheus.
Yeah, it is correct. So the Prometheus part here is only acting like a matrix collector and send a matrix to the AMP workspace. So you don't necessarily need to assign like a lot of like storage to this Prometheus, or you can disable it as well. But by default, we just have it there for maybe catching bubbles. So you don't have to like assign a ton of like storage to this Prometheus part. So it's only collect the metric and store it like maybe for a couple of days instead of for like a long time thing, because all of the metric is now available in the AMP space.
Got it. That makes sense. All right, so we are getting a few minutes past the end of our time here, but I really did want to give you that opportunity to show this demo. I think that this last integration with AMP is fairly critical. So last thing here, I want to give you folks an opportunity to share any final words, anything that you want folks to do. For example, anyone that might be watching that wants to contribute or get involved, what's a good way to get started? Lynn, Webb, I'll pass it back to you.
Yep. Thank you, Sai. So, and it is really great to have a chat with you today. And if you have any additional question that you have after this live session, you can also always contact us using the link that I share on the screen here. Or I guess after this being recorded, you can also find that information in the video as well.
I'll just second what Lynn said. Thank you so much, Sai, and for all that joined and for the amazing questions throughout this. Reach out if you think we can be helpful in any way, whether it's like, supporting, this like, free collaboration or, services or training, anything else. And then also if you're interested in getting involved in the community, you can go check out OpenCost.io was linked earlier, as well as like GitHub Kubecost projects. So lots more, if you do want to get involved. And again, we welcome all like contributions and feedback, and anything we can do to help. We'd love to hear.
Awesome. Thank you. Again, Webb Brown, co-founder, CEO of Stackwatch, creators of Kubecost, and Linh Lam, solutions architect at Stackwatch. Thank you so much for joining us today, folks. And I think this was a very, very helpful session, especially from all the comments we got. Clearly, I think there's a lot of interest in the space. And I've myself got my Kubecost shirt on today. And I'm sure I'll be seeing you folks next month at KubeCon NA in Detroit. So really looking forward to that. Thanks again so much. And be sure to join us for the next time we do a live stream here, folks. Be sure to subscribe. Thanks for watching.
Thank you, Sai.
Thank you, everyone.